Hello everyone, welcome again to your channel Maths Guide. In today's lesson, we will learn about the different types of sets in mathematics with simple definitions, clear examples, and easy tricks to remember them. So let's begin. Now let's understand one by one what are the different types of sets in mathematics. And there are subset, superset, proper set, improper set, equivalent set, equal set, overlapping set, and union intersection of sets. Now let's understand them one by one. Now we have the first type of set that is called subset. If all the elements of set A are also elements of set B, then A is called the subset of set B, and we will write it like this, that A is the subset of B. This is the symbol of subset. Just keep this symbol in your mind. Now look here in example. If set A has element 1, 2, 3 and set B has element 1, 2, 3, 4, 5, 6. Okay, as the elements of set A are also the element of set B, then we can say that set A is a subset of set B. Okay, then if A is a subset of set B, then what is the set B to A? Now let's see. As I told you, the set A is the element of set B, so it means A is the subset of B. So then we can say that if A is subset of set B, then B is called the superset of set A. So they are interlinked with each other. If one set is subset of another set, then the second set will be the superset of that set. So we can write it like this, that B is the superset of set A. This is the symbol of superset. Now we have a proper and improper subset. First of all, we have to understand how can we find a subset of any set. Let's watch it very carefully. We have a set 1, 2, 3. Any set A, B, C, whatever name you can give to this set. We have to find out the subset of this set, and we will write all the possible subsets which we can make from this one set. Remember, while writing the subsets, first of all write then empty set, as an empty set is always a subset of every set, like this. First of all, we will write the empty set. Then we will write all the singleton elements we can make from this set. We have 1, 2, 3. They are all singleton sets we can make possibly from this set. Then we will make pair of elements 1 and 2, then 1 and 3, then 2 and 3. These are the all pairs we can make. And in the last we have the set of 1, 2, 3, these three elements. Now we have to differentiate between the proper sets, subsets and improper subsets. Those subsets which are not similar to the original set are called proper subsets, and the subset which is similar to the original set is called an improper subset. So every subset has its proper subsets and improper subset. So the blue subsets are called proper subsets and green subset is called the improper subset of this set. Now two more very easy concepts. Now we have equal sets and equivalent sets. Previously we were talking about subsets. Now we are talking about equal sets and equivalent sets. Very easy to understand. Equal sets are sets if the elements of any two sets are same. For example, in set A we have A, B, C, D. In set B, we have B, C, D, A. No matter what arrangement they have, there should be the same number of elements and same elements between them. A, B, C, D, B, C, D, A. As the elements of both sets are same, so we can say that they are equal sets. But in equivalent sets, the elements may or may not be same, but the number of elements must be same. It means if set A has 4 elements, set B also have 4 elements, we can say they are called equivalent sets. So here the number of elements should be same, but in equal sets the number of elements and the elements themselves must be same. Okay, so equal sets are always equivalent sets because the number of elements are same, but equivalent sets may or may not be equal set as the number of elements are same, but the elements themselves may vary. Now the next concept is disjoint sets and overlapping set. As it is understood from the name, disjoint means there is nothing joined between them. They are separate. So let's see. If set A has element A, B, C, D and set B has elements E, F, G, H, disjoint means there is nothing common between these two sets. All the elements of set A are different from all the elements of set B, so they are called disjoint sets. No common element. But in overlapping sets, we have set A and B must have at least one common. Then they are called overlapping sets. It means if set A has 3, 5, 7 and 9 and set B have 3, 4, 6 and 9, so we can say that two elements are common, 3 and 9 are common between these two sets, so they are overlapping sets. As 3 and 9 are common elements, so they are called overlapping sets. Now it's a very important concept of how to find the union of sets. As it is clear from its name, union means uniting. So we have to unite the elements of the given sets. For example, we have in set A 1, 2, 5 and 8. In set B we have 1, 3, 5 and 6. We will unite them. We will combine all the elements of set A and B in one set, in one single set. Okay, so first of all we will write in symbolically like A union B. We write it like this, A union B. Okay, A union B means we have to unite this elements of set A, then union elements of set B. So we will write it as A union B is 1, 2, 3, 5, 6, 8. Keep the points in your mind. Do not repeat any element and do not miss any element. This is very important while making the union of sets. This is exercise 1.9 question number 1 and we have to find out the union of sets. As I have told you very clearly that union of sets mean we have to unite all the elements of the sets. But make sure that each and every element should be unique. It means no element will be repeated. So let's start. Question number 1, exercise 1.9, part 1. The set A has elements 1, 4, 7, 10 and 13 and set B has 2, 3, 5, 8 and 9 and we have to find out the union of set. First write out the symbol A union B. Yes, A union B is equal to set A union set B. Now we will in the next step unite all the elements and when we will unite them in ascending order, we will write the union of set like this. This is how we can find the unit of set. Make sure no element should be missed and no element should be repeated. Now part 3. Here we have set E, A, B, C, D, E and in set F we have A, E, I, O, U. Okay, now we have to make the union of these two sets. First of all, we will write the symbol E union F is equal to set E union set F. Okay, then uniting all the elements we have this is called the union of set E and set F. Now intersection of sets. Intersection of set means there must be some common between the elements or we have to find out the common elements. But if there is nothing common, it means your answer will be an empty set. Now let's check it out. We have set A 1, 2, 5 and 8. In set B we have elements 1, 3, 5 and 6. Can you see something common in between these two sets? Any element that is also the element of set A and also the element of set B? Yes, 1 and 5. 1 and 5 are common elements. So we will find the intersection of set. First of all, write the symbol A intersection B. This is the symbol of intersection. You have to keep in mind all the symbols and note down in your notebook the symbol of each and every concept. A intersection B means set A, then intersection set B. Now we have to write the common elements in the answer that is called A intersection B is 1 and 5. This is the concept about intersection of sets. They are also called overlapping sets. Now exercise 1.1 question number 2. Now we have to find out the intersection of sets. In the union of set we united all the sets, but in intersection of set we have to find out the common elements. Set U has 0, -1, -2, -3. It means negative integers and in set B we have 0, 1, 2, 3 positive integers, and we have to find out the common elements between these two sets. Yes, it is obvious that we have to write out the symbol first, then we will write set U intersection set B. This is called in U intersection B. So our answer is a singleton set with single element 0. Next question we have Y and Z. Y has multiples of 5 and Z has all the natural numbers. Now we have to find a common. Obviously, we will first write the symbol of intersection of these two sets Y and Z, then set Y intersection Z, and as you all know, only these elements will be common as the next set Z has all the natural numbers, so these numbers are included in these natural numbers, so it means this set is the common elements of this set also. So our answer will be 0, 5, 10, 15, 20 are common elements between these two sets. Now exercise 1.9 question number 3. We have a set of natural numbers. N belongs to natural numbers 1, 2, 3 and so on. And this W means whole numbers and it belongs to all the numbers included 0. And we have to find out two things. N union W and N intersection W. First of all, we will find out the union of these two sets. Finding union of N and W, we will write set N union set W. And after uniting them, we get 0, 1, 2, 3, 4, 5 and so on. We have united the 0 with this set and we have all the numbers included 0. Next, we have to find out intersection. In intersection, 0 is just not common. Rest of the elements are common. So in our intersection, we get all the natural numbers. Next is 1.9 question number 4. We have set E, it means set of even numbers, and we have set O means set of odd numbers, and we have to find out the union of these two sets and intersection of these two sets. Let's first find out the union of these two sets. The union of set E and O means we have to unite both the elements of the sets, and obviously we will get the set of whole numbers in the answer as we have united all the sets. Now finding the intersection, as there is nothing common between the even numbers and odd numbers, so it means the intersection of these two sets will be having an empty set. So this was all about different types of sets and their concept with examples and exercises solutions. The next exercise will be about finding the difference of sets and the complements of set and their properties. Don't miss out all the lectures and don't forget to share, like and subscribe to my channel.